Differentiation and integration of power series. In Theorem 9.21, the properties of function defined by power series, if the function is f of x is equal to summation of a sub n times the quantity of x minus c to the power of n, when this is equal to a sub 0 plus a sub 1 times the quantity of x minus c plus a sub 2 times the quantity of x minus c squared plus a sub 3 times the quantity of x minus c cubed plus so on. So then the radius of convergence is equal to greater than 0. Then the interval is the quantity of c minus r and c plus r. So f is differentiable and therefore it is continuous. So moreover, the derivative and antiderivative of f are as follows. So first, so f prime of x is equal to summation of n8 sub n times the quantity of x minus c to the power of n minus 1 when n is equal to 1. So we have here a sub 1 plus 2a sub 2 times the quantity of x minus c plus 3a sub 3 times the quantity of x minus c squared plus so on. So in number 2, we have here the integration of f of x dx is equal to c plus summation of a sub n times the quantity of x minus c to the power of n plus 1 all over n plus 1 when n is equal to 0. So we have here c plus a sub 0 times the quantity of x minus c plus a sub 1 times the quantity of x minus c squared all over 2 plus a sub 2 times the quantity of x minus c cubed all over 3 and so on. So the radius of convergence of the series obtained by differentiating or integrating a power series is the same as that of the original power series. So the interval of convergence, however, may differ as a result of the behavior of at endpoints. So, for example, here consider the function given by summation of x to the power of n all over n. It is equal to x plus x squared all over 2 plus x cubed all over 3 and so on when n is equal to 1. So find the interval of convergence for each of the following. So integration of f of x dx, f of x, and f prime of x. So f prime x is equal to summation of x to the power of n minus 1. So when n is equal to 1, so it is equal to 1 plus x squared plus x cubed plus x to the power of 4 plus x to the power of 5 and so on. So the integration of f of x dx is equal to c plus the summation of x to the power of n plus 1 all over n times the quantity of n plus 1 when n is equal to 1. So it is equal to c plus x cube all over 1 times 2 plus x cube all over 2 times 3 plus x to the power of 4 all over 3 times 4 plus x to the power of 5 all over 4 times 5 and so on. So by the ratio test, you can show that each series has a radius of convergence or it is equal to 1. Then considering the interval negative 1 and 1, you have the following. So muna ni siya. So for integration of fx dx, the series is summation of x to the power of n plus 1 the all over n times the quantity of n plus 1, and then the interval of convergence is at negative 1 and 1. So the converges for x is equal to plus and minus negative 1, and its interval of convergence is negative 1 and 1. So we have here muna ni siya ang ato ang graph. So for f of x, the series is summation of x to the power of n all over n when n is equal to 1. Then the convergence, yung interval is negative 1 and 1. So it is converges for x is equal to negative 1, and it is diverges for x is equal to 1. So C, its interval of convergence is -1 and 1. So kindly look at this figure. So the interval of -1 and 1, the iyang center is 0. So mauna na siya ang graph niya. For f prime of x, so the series is diverges for x equal to plus and minus 1, and its interval of convergence is -1 and 1. So mauna ni siya iyahang graph gihapon, same as sa graph atong sa integration. So that would be all. Thank you.